further look at power functions where the powers are either even or odd positive numbers, we can see that there's some similarities, and we're just kind of following up on the previous pages. The graphs that have an even power are generally some sort of a U shape when that k is greater than 0 again. And we see this U shape here, are both ends going in the same direction. Whereas if it's an odd power, we see that the ends are going in opposite directions. This one's going up, this end's going down, this end's going up, this one's going down. But they're all odd powers. X to the 5th, same idea, but you notice you can see that flattening out on all of these graphs and how it rises pretty quickly. So the graphs of even powered functions and k is positive, in other words, the number in front is positive. We'll talk about when it's not here in just a minute. But when it's positive, we see that we have symmetry about. Now take a look at the even powers and notice what axis you can fold those graphs over. You're going to be folding it over the y-axis, and it's going to lie on itself. So we say that it's symmetric about the y-axis, and the graph touches and turns at, right there at 0, 0, or the origin. The graph of odd-powered functions, except for power 1, where y equals kx to the p, k is positive, exhibits, when we take a look at these, notice opposite quadrants have the same pictures in them. So when opposite quadrants have the same picture, we say that it exhibits origin symmetry, or symmetry about the origin. So again, notice the O's go together, opposite quadrants, origin. The graph passes through the point 0, 0. It actually will cut through that point as opposed to touch and turn. So if I do have a negative in front, it's just going to flip it around the x-axis, and they're going to be mirror images of each other across the x-axis. So describe the end behavior of the following functions. Well, the first thing I want to notice is the power. The power's even. So if the power's even, they're going to go, the ends are going to go in the same direction. If there's a negative in front, they're both going to go downward, just like y equals negative x squared when we talked about looking at a picture like that. Both ends go down, and the same thing here. A negative and an even power, both ends down. Here's another even power, so I know the ends are going to go in the same direction. Because it's positive in front, both ends are up to the positive direction. And these odd powered ones, even this one, this is x to the 1 on there. Odd powers, that means the ends are split. So I have to think of this maybe in terms of like a line. Think about if there's a negative for a slope. We know that negative for a slope means it's going downhill, or the left side is up and the right side is down. Now, even though this isn't a line, we can still think of it that way about how my ends are going to behave. If it's an odd power, the ends are going to be split. I have to figure out, is it going downhill or is it going uphill? If the number's positive in front, the line's going uphill, so the left side is down and the right side is up. You could type this into your calculator and take a look at it. Go in here, let me clear out all this stuff, and then just type in 3x to the 7. And notice the left side's down and the right side's up. Left down, right up. All right, now for this one, negative 2.5x to the 9. So I focus on the power. It's an odd number, so the ends are split. And if it's negative, it's going downhill. So the left side is up and the right side's down. But you can confirm that with your calculator. Type in negative 2.5x to the ninth. Take a look at the picture. That'll convince you as well. So the bottom part here, I'll let you read through that on your own, but it talks about if k is a number bigger than 1, it's going to get stretched. If it's a fraction between 0 and 1 or a decimal between 0 and 1, it's going to compress it. So you can kind of take a look at 0.25 versus a 10 in front. The 10 goes up pretty quick, it's stretched. The 0.25 kind of compresses. It's gotten flattened out. That's what we mean by compressed. All right. Same way with the even powers here. If it's bigger than 1, we tend to see it go up real quick. But if it's a fraction between 0 and 1 or a decimal between 0 and 1, we see that it's going to flatten or compress. Won't go up quite as quick.